All right, here we go again. So this is our last video of the discrete and continuous, well, of my videos. So today, or what we're looking at right now, is we're looking at situations. So we want to determine whether a situation is talking about discrete data or continuous data, okay? So let's just get right into it. So number 7 tells me a graph of how many Xbox games you have when you receive one for every great report card that you get, okay? So for this one, the key thing that this sentence is talking about is it's talking about a graph of how many Xbox games, okay? So if we're thinking about Xbox games, right? If you have one Xbox game, you're good, right? You can have 2 Xbox games, 3 Xbox games, 4 Xbox games, all the way on, right? But what you can't have is you can't have 1.5 Xbox games, right? You can break a disc in half, but then it's not an Xbox game because it doesn't work, okay? So Xbox games need to be whole numbers, which means they are discrete data. So this scenario is discrete, okay? Number 8, a graph of the temperature as it increases throughout the daytime, okay? So the key word here that you should be noticing is temperature, okay? The graph of the temperature. That's what the graph is of, okay? So what might be good to have on hand here is the notes from the other day. So if you take a peek at the notes that we did the other day, some of my examples I wrote, oh, look at that, temperature. Temperature is an example of continuous data, okay? So we're gonna go and write continuous. Okay? And the reason it's continuous is because the temperature can be, 70.5 degrees, 80.2 degrees, okay? They can be decimals. Number 9, a graph of the amount of money you are earning if you have a job walking dogs and get $5 for every dog that you walk. So number 9, we're talking about the amount of money, okay? So we're talking about money. So if we get $5 for every dog that we walk, right? So if we walk 1 dog, we get $5. If we walk 2 dogs, we get $10. 3 dogs, $15, and so on, right? So in that, there is no decimals. We're not talking about any decimals right now, right? You can't have $5.50 in this scenario, okay? So in this scenario, we're gonna call this discrete data, okay? So money is a kind of tricky one, but we'll come back to that. But in this scenario, it is discrete data. Number 10, a graph of your height as you get older. So here we are talking about height, okay? So again, if you remember from the notes, look at that. Height is continuous. So we're gonna write continuous. And again, it's continuous because you can be, 5.5 feet tall. Like your dog can be 2.5 feet long, right? Your height can be decimals or fractions. Number 11, a graph of the number of words you can type correctly while you are in a keyboarding class. So we're talking about number of words, okay? So if we're talking about the number of words, right? You can type 30 words per minute, 28 words per minute, right? 70 words per minute. But what you can't do is you can't type 30.5 words per minute, right? You can't type 30.1 words per minute, right? You can either type a word or you can't type a word, right? So we're calling this discrete data. Okay. Number 12. So a graph of the height of a football above the ground after it's kicked. So height, we've seen that one before. That one was like right up here. Height is still continuous. Not trying to trick you. Okay. 13, a graph of how far you are away from your house when you go on vacation. So we are talking about here, it's kind of worded weird, a graph of how far you are away, okay? But another word for that, simpler word that is in the notes, is called distance, right? How far you are away from something, that's the distance you are. So distance is continuous. Right? We can be 30 miles away from home. We can be 28.5 miles away from home. We can be 30.2 miles away from home, right? So distance is continuous. Number 14. So Number 14 says a graph of how much time you spend on Schoology this year. Hopefully it's a lot of time. But we are talking about how much time, okay? So again, if we look back to the notes, time is continuous, right? So we can put continuous here. Okay, and that's because you can spend, you know, an hour and 3/4, or no, 1 3/4 hours on Schoology. You can spend half an hour on Schoology, right? You can spend an eighth of an hour on Schoology, like some of y'all have. But some of y'all, you can put in 3.5 hours on Schoology, right? So time is continuous. Last one for today. A graph of how many masks you've gone through since March. So we are talking about masks, the many, many masks that we've gone through. So if we're talking about masks, right, we can have 1 mask, 2 masks, 3 masks. We can't have half a mask, right? I mean, we could, but it would just cover our mouth and not our nose, which is wrong. We want full masks that cover everything. So masks need to be discrete, okay? They are discrete data, okay? So hopefully y'all can see the pattern through this notes, right? It is going to take practice, and you're going to have to kind of go through some scenarios on your own to try to figure it out. But for now, if you have any questions, you can ask your teacher, and that's all. So have a good day.